Hello everyone, my name is Shannon Kendall. Welcome to my regular expression tutorial, Demystifying that regex stuff. I do take a JavaScript approach to this tutorial because that's my primary coding language, but if you write in another language, this tutorial is simple enough that you should be able to follow along and then just reference your own language's documentation afterwards. So I first came across regular expressions early on in my baby coder days. I had completed maybe 2 tutorials online and was trying my hand at Code Wars, and I came across a challenge called Dubstep that asked us to take a string which represented dubstep lyrics and return the original sample lyrics by removing all the WBs and inserting spaces. It looked something like this. And I thought to myself, well, I've completed 2 online tutorials and I totally understand conditional statements and loops, so I can totally do this. And I totally couldn't. I struggled for quite some time until my code looked something like this. It was pretty awful. I don't think that even runs. I think I just got frustrated and gave up and wanted to see what other people were doing because I just couldn't do it anymore. And that's when I saw the first top solution. It was a single line of code, and I didn't even understand half of what was going on in it. I just felt instantaneously so dumb and like I would never get anywhere with my coding. Seriously, what black magic are they weaving out there? It turns out it actually wasn't that complicated. It just had 2 things I'd never seen before. The first was a regular expression, which is commonly known as regex or sometimes regexp, and a regex-friendly JavaScript method. Fun fact, JavaScript actually has its own regex class with its own specific methods and properties, meaning it's an object, kind of like the string object or the array object that we all know and love. So what is regex? Regex is essentially a low-level language. It's very similar to machine language, but it provides us a specific compact way to search through strings and large bodies of text. Common uses include validations like emails or phone numbers, searching and extracting for words in a sentence or unwanted characters, replacing or reformatting like renaming files in bulk, and splitting strings using a JavaScript method. But how does it work? In JavaScript, the regex search consists of 3 parts. The string against which the search is performed, known as the subject, the match method, provided by the JavaScript global regex and string objects, and then the actual regex, which is a set of characters that represent rules for searching a pattern within the subject. So as an example, if this was my phone number, it's not my phone number. I can pass my number in as the subject, call the test method on it, and then pass in this regex pattern, which would return true because 916 occurs in my phone number. But if I pass in 212 as a regex pattern, it would return false. And then if I put 916 separated by the OR operator in 212, it would return true. If you're wondering what the / situation is before the regex patterns, that's what indicates to the search engine that is where the search pattern starts and ends. So let's break down that regex black magic. Regex can search for literal patterns like help, but more often it's comprised entirely of special characters because it allows it to be a lot more flexible. So the regex special operators include an OR operator, which is very similar to the JavaScript OR operator, in that it will match against either the pattern preceding the operator or the pattern following the operator. There are character sets, which are wrapped in square brackets. And that represents one position in the string. So each of these character sets would represent one lowercase letter a through z or one lowercase letter 0 through 9. But you can add in multiple ranges to add a variety of pattern possibilities. So this one, for instance, would match only lowercase letters a through g or r through w for that one space. And additionally, if you put a caret at the beginning of a character set, it will tell the engine to not match any of the characters inside the set. So this would tell the search engine to not match any vowels at that position. There are also quantifiers or repeating operators. A plus sign will match one or more of the preceding character set until it no longer repeats. So yes with a plus sign will match yes and yes. A asterisk is very similar, but it will match 0 or more of the preceding character set. So LOLZ asterisk will match LOL or LOLZ or LOLZZZ. There's also a question will match 0 or 1 of the preceding character or set. So that kind of makes it like an optional character. So this pattern would match both JPEG with or without a G. And then finally, a number or interval wrapped in curly brackets is known as an interval expression and will match the preceding character that number of times or within that range of times. So this would match yo with 2 O's, but not yo with 1 O, because it requires there to be 2 of the preceding character. Whereas this will match either 2 Y's, 3 Y's, 2 O's, 3 O's, but not the actual word yo because it's a character set. There are also modifiers, which are known as flags. Those are located outside of the forward slashes and provide special rules for the search engine to use. I, standing for ignore case sensitivity, will tell the search engine to match both upper and lowercase letters. G, which stands for global, will tell the search engine to grab every match found in the subject, so globally all of the matches. And then there's an M, which is a multi-line flag, and that's used for when the subject has line breaks, and I'll get more into that a little bit later. There's also meta characters, which are really cool because they allow a lot of matching possibilities. This is the white space meta character, and it will match any space, tab, new line, which is like a break in a string. There's the word meta character, which will match any alphanumeric character, a number or a digit, whether it's upper or lowercase, along with underscores. So it's really useful for like screen names. There's the digit meta character, which obviously matches any digit. A boundary meta character, which wraps around the beginning and the end of an entire word and tells the regex that it will only match if the entire word matches that pattern. So if that pattern is found in a substring of another word, it won't match. And then there's the wildcard meta character, which is a little dot, and it'll match any character at all. So, for example, the string my aim screen name was scrunchies are forever 88 will match with this pattern, which tells the engine to grab an entire word that starts with scrunchies and then has any alphanumeric character or underscore in it. So it grabs scrunchies are forever 88. Fun fact, that is actually not my aim screen name. There are anchors, which start at the beginning and the end of a regex pattern inside of the forward slash. So a caret at the beginning indicates that the regex pattern begins matching at the beginning of the subject, and a dollar sign indicates that the regex pattern finishes matching at the end of the subject. And you don't need to use both of them. You can use one or the other for accuracy. This is where the M modifier comes into play, though. So if you want your pattern to match against an entire line in a multi-line subject, you can still use the anchors and then put the M modifier flag, and then it'll match against a whole line, not the entirety of the subject. And finally, there are groups, and that's subset of the pattern that's wrapped in parentheses. Among other things, this allows for clarity while using the OR operator. So let's try this out by searching for an address. We can write a pattern that will search for any standardly formatted address, and it's pretty long, so I'm going to break it down into chunks. So for the street address, this pattern will match any number of digits that will be the building number, and then there will be a space, so I've used the space meta character. And then this pattern will match the street name, and I've accounted for if it's a street name with 2 words in it. And then this will match anything between this abbreviation for street and like the entirety of boulevard. So any word character that is 2 to 9 characters long. And then finally a comma, a literal comma, and a space. Then there's the city. Similar to the street name, this will match a city name, so it can have 2 words in it. And then this will match the comma and the space following the city name. The state abbreviation, this pattern will match exactly 2 word characters followed by a space, and then the zip code, which will match exactly 5 digits. So if we put it all together, this lovely, terrifying looking string, but we know that it all works, and it will match any standard formatted address, like this one that I actually made up off the top of my head, as well as this totally not real address I also made up off the top of my head. But wait, there's more. If we wrap sections in parentheses, it creates a matching group that captures the group's value and returns it with a match. So taking our pattern and wrapping these subsections in parentheses and then running it through this, it returns an array that has the entire match string as the first index and then each subsequent captured value in the array. So think about it. Think about what you can do. You can seed a database with this information. And matching groups can be nested for even more powerful capturing. But I did mention using the OR operator. What about situations when parentheses are used to group options but not capture them? In that case, you can put a question mark colon at the beginning of a match group, and that prevents a search engine from capturing it. It just lets it pick this or that. So let's take our regex pattern and put it into our code. There are a few methods to do that. There's the regex prototype.exec, which is a regular expression object prototype, and that takes a string to search and returns an array with the entire matched value followed by any values captured by in parentheses. And then there's the test method that just takes a string and returns true if the string contains a matched value. There's also a regex constructor, so you can pass a variable in to it as the first argument and an optional flag as a second, and that will construct your regex for you. Sorry about that popping up, it's really annoying. But this regex constructor allows you to use variables, and that can become really handy when you're coding. And then regular expressions can also use the string object methods. So match, which you've seen earlier, it takes a regular expression and matches against a string, returning the array, similar to exec. There's replace, which takes 2 arguments, a string to search for and a string to replace with. There's string prototype.search, which takes a regular expression and returns the index of the first match or -1 if there's no match made. And then there's string.prototype.split, which takes a separator in the form of a string or a regex pattern and returns an array with a string split into elements wherever the separator is matched. Some final tips and tricks when you are constructing your regex. Whenever possible, do anchor your patterns for accuracy. It just gives you a lot more control and specificity. Along that lines of specificity, say what you want and what you don't want. Utilizing contrast aids that. So in this pattern, it will match any hashtag, but it'll stop matching at any trailing spaces or punctuation. So I told it what I did want and also what I didn't want in case people jammed all of their hashtags together. This will grab them each individually. And then JavaScript actually does have the worst regex engine out of all languages. It's still pretty cool though. So here's some reference sites that I found really, really helpful. Regexer is really common. It allows you to build your regex pattern against some sample text with like highlighting so you can see what you're actually grabbing. It also has kind of a great glossary and sample cases to refer to. There's also rexegg.com, which is a T-Rex themed site that covers regular expressions in a really thorough way and handles things that are often glossed over by other reference sites, so it's definitely worth looking into. And then obviously check out MDN. It has thorough explanations of the JavaScript methods utilizing regex, as well as some examples for you to reference. And also check out, there's some idiosyncrasies in the regular expression global object, so definitely just make note of those. That's it for my tutorial. I really hope that it helped lift the veil and not make regular expressions feel that intimidating, they're actually kind of really cool and fun, and I think you'd get excited anytime you get to utilize them. All right, thank you for listening.